we continue on with solving inequalities that have variables on both sides, variable terms on both sides, but that variable will be the same because we're solving ones in one variable. Today, we have to make sure that before we do that, we've already mastered that skill, but before we do that, we have to make sure we can simplify that inequality before we do the solving steps. So we're going to say right here, fill in the blank. Sometimes you will need to simplify one or both sides first. So you're going to look at both sides and you're going to say do either or both need to be simplified before I go about doing the same thing on both sides to solve it. Okay? So sometimes we're going to have to simplify them first, and then we'll go about solving them. So let's just start practicing here. Number one, does the left side need simplifying?
Yes.
Yeah, we need to do, what's that property called we need to do here? Distributive property. So remember what we said we're going to do though, whenever we do distributive property, we're going to change subtraction to add the opposite. So we're going to make that 2 plus a negative x, and we're going to make this x plus a negative 2 on the other side. Okay? Let's change our subtraction to add the opposite. Yes, Cody?
Could we also put a 1 in front of the x?
And you can also slip a 1 in there, so it would be a negative 1x. And over here we can make that a positive 1x if we want, okay? So those things that will help us maybe be more successful. So we're going to do distributive property. We're going to take that 5 and we're going to distribute it to the two terms inside the parentheses that are part of that addition problem. That's how we get rid of the parentheses. So 5 times 2 is?
10.
10.
Plus negative 5x.
Plus negative 5x. That's what the left side of our inequality simplifies to. We have to do the distributive property because what's inside the parentheses can't be combined. They're not like terms. Is greater than or equal to, we're not doing any solving yet. That doesn't need to change for any reason. Do we need to simplify the right side?
Yes.
And we have simplifying to do over there also. So again, we'll do our distributive property. What's its simplified expression name, Cody?
3x plus negative 6.
3x plus negative 6. Okay. Is there any other simplifying to do? Remember, simplifying steps look like this. If you have parentheses, there's multiplication going on, you might need to do distributive property, which we just did. Another simplifying step is, are there any like terms on the same side that can be put together? Now, here's what I'm saying. I don't want us to solve yet. I'm asking, are there any like terms on the same side that can be put together? So are there? Do we have any like terms we can do any combining with? No, we don't. This is ready to solve, isn't it? We're done simplifying it. Okay, who wants to give us the first move? What move should we make? Okay, Cody, what move do you want to make?
If we want to keep the x on the left side, we'd subtract 3x from both sides, or we could start with subtracting 10 but on both sides.
Okay. I like to always work with the variable parts first. Get rid of variables on one side or the other. So can I go with your first move? Okay, so the first move you said a good one to make would be to subtract 3x from both sides. And his reason was, you know what, I like the variable to be on the left side. It's going to create a negative, but at least it might make it easier to graph in the end, right? Okay, so what do we have now?
10 plus 8x, negative 8x, is less than, no, is greater than or equal to negative 6.
Yeah, okay. Because when we have a negative 5x, take away 3x, we could change that to add the opposite, and we are actually adding two negatives together. When you add negatives, they stay negative. Negative 5 plus negative 3 is negative 8. And I need you to stop letting that calculator do your thinking for you. You guys are just going to it way too often. You can do this, and you have to be able to do it, okay? So, what would be our next move now? Add 6 to both sides? Okay, if you add 6 to both sides, you're actually going to just create an extra step for yourself. You could do that, Julia. but then you'll just create a 0 over on that side, and then you'll still have to move the 10 over anyway, okay? So Julia's not wrong in saying you could add 6 to both sides, because you can. And I'm just going to show you, I don't mean that you need to do it, but if we add 6 to both sides, here's what it will look like. Let me put it there instead. Here's what it will actually look like. It will have 16 plus negative 8x is greater than or equal to, what's negative 6 plus 6? 0. Okay, so we still, what we did, if we do that, we actually just end up creating an extra step. Okay, so Cody?
If we follow along with Julia's step, wouldn't you have to subtract 16 from both
Yeah,
sides?
now we have to subtract 16 from both sides, and we'd still end up with the same thing as if we would have subtracted 10 from both sides. We should, so let's just stay with it. I think that some of you are already doing it anyway, so we might as well just continue on. Let's subtract the 16 now from both sides. We could have subtracted 10 instead of adding 6, but we'll go with our adding 6. And now we're going to subtract 16 because we're trying to get that negative 8x alone. So now negative 8x is alone is greater than or equal to
Negative 16.
negative 16. 0 take away 16 takes you to negative 16. Okay, what will be our next move now? We have to do this move. What is it? Abby? Yeah, we divide both sides by negative 8. So negative 8x gets divided by negative 8. To get that x alone, negative 16 gets divided by negative 8. Cody?
And your less than or greater than or equal to changes to a less than or equal to.
Yeah, we're going to have to switch our symbol because we divided by a negative, so it's going to become is less than or equal to. Negative divided by a negative is a?
Positive.
Positive. 16 divided by 8 is?
2.
2. We do not need a calculator to do that. X is less than or equal to 2. And now we'll graph it. And because we made it so that the variable was on the left, when that's the case, whatever direction the inequality symbol is pointing, it's this direction we end up shading, isn't it? Okay, anybody have questions, any part of that you want to go back and talk about? So now again, I just want you to see that we just ended up, what we ended up doing is just creating an extra step for ourselves. What we could have done back here is instead we could have subtracted 10 from both sides, and we would have ended up with negative 8x is greater than or equal to negative 16. So see how we just ended up creating an extra step in there that we didn't need to create, but we still should end up with the same answer. So we can create more work for ourselves, that's okay. Okay, how about number 2? Do we have any simplifying to do before we solve? Yeah, which side or sides? Both? How about the left side? Does it need simplifying?
Yes.
Yeah, so let's change it to add the opposite first. Instead of subtract 3, we'll make it add the opposite of 3, which is negative 3. And then we'll do our distributive property. What's its new name now? That left side. Yeah, 2m plus negative 6 is less than. Any simplifying to do on the right?
No.
They're not like terms? No, they're not. So we're going to have to just leave it 3 plus 3m. Are we ready to solve? Okay, now we're ready to solve. You go ahead and solve this because you know how. Let's see if we can all come up with the same answer. Okay? You already know how to solve these. This is what we did for today. Let's see who. I'm going to do probably a different method than you do. So. I did it, so my variables ended up on the right. But in the end, we should end up with the same answer anyway. So if you didn't end up with m is greater than -9, either you need to find my mistake for me, or you need to find your mistake. AKA, also known as, in other words, making it so that it's graphing friendly. I'll do it both ways, just to see what happens here. Whoopsie. Okay, so notice how when I did it both ways, if I moved the variables to the right side, it actually was less work than if I moved them to the left side, or to the right side. If I moved them to the right side in the first one, that was less work than if I moved them to the left side. Cody?
When you did the first one, when you moved to -2m, you created a +1, and then you still ended up with the same answer because you always have to, you always want to switch the m to the variable to the left side.
Right, so in that one, I switched the symbol because I wanted the variable moved to the left side. On the one that I did it on the right, I had to switch it because I divided by a negative, right? So we have to end up with the same answer. There's only one solution for this, no matter how we go about it. And then, of course, it should be graphed. Integer neighbor to the left.
-8 or -10.
-10. Integer neighbor to the right.
-8
-8. Which way should this be shaded?
to the right.
To the right. Good thing I got you, Cody. Okay. Were you all successful? Arms up if you were successful. If you weren't, have you found where you went wrong? You're all going to claim to be successful. Good job. Okay, let's go to the back side then. Oh, lovely decimals. Does that make this unsolvable?
No.
I hope not. Does it need any simplifying?
No. Oh, well, yes, on the left side.
What does it need?
Add the opposite.
Okay, that's not called simplifying, by the way, okay? That's just called renaming it to make it easier to work with, okay? That's not simplifying. Changing to add the opposite is not simplifying. So, let's clarify that. Simplifying is doing distributive property or combining like terms. Okay, do we have to do either of those?
No.
No, okay. So, if you don't want to change it to add the opposite in this one, sometimes we don't in these, we just go about solving it. What should be our first move?
Subtract 0.3x on both sides.
Okay, subtract 0.3x on both sides. Now, if we didn't change this to add the opposite though, here's what I'm afraid will happen. We won't keep that the way we're supposed to. 2.4x take away 3/10x.
2.1x.
2.1x, okay? Plus a -0 and 3/10 is greater than or equal to 6. Okay, now this is when I'm pretty sure you guys just want to take your fingers to your calculator, don't you? Anybody tempted? Go ahead and get it, because you know it's decimals. It's not as much fun. Okay, what should we do next? Okay, add the 0.3 to both sides. So now the left side is 2 and 1/10 x is greater than or equal to what?
6.3.
6.3. Now, so far we really should not have needed to use our calculator at all. And I really am feeling like I want to say to you, you shouldn't still even for the next step. But you might disagree with me. 2.1x divided by what?
2.1.
2.1 is greater than or equal to 6.3 divided by 2.1. Do we really need a calculator? How many 2.1s do you think you can take out of 6.3?
3.
3, exactly 3? Yeah. So x is greater, did we divide by a negative?
No,
No? Okay. Yes, Cody?
I see something.
What?
Can I show you up there?
Sure, come on up.
I think I've just found a way to easily get your answer when you have decimals. You see, you have 1 goes into 3 times.
Okay.
2 is multiplied by 3 to get 6. You get 3. You have 3 for both of them.
Okay. So you're thinking then that, yeah.
That's our answer.
Yeah. If you, yeah, good job. Okay, let me show you. I want everybody to do this with me because I want to make your life easier when, because this happens. You have a problem on a standardized test and it says no calculator. And you're like, oh my goodness, I'm so bad at long division and with decimals, I just am no good at it. So let me show you something that you can do to get rid of decimals and not even have to deal with them. Okay? So let's rename the problem. Well, by the way, let's get this graph though first, and then we'll just rework it but not graph it again. Okay? So if you haven't graphed it yet, go ahead and get it graphed. Okay, and then I want you to put on your paper that we're going to do a make it easier, and then you can say maybe you won't think it's maybe you won't think it's an easier way. I like to do this when I have decimals involved. Okay, so what I'm going to do is I'm going to write down the problem the way it was to start with. It was 2.4x. You should be, don't you have all the rest of this side left to do this, right?
Yeah.
Minus 0 and 3/10 is greater than or equal to, I can't remember what else it was.
0.3x plus 6.
0.3x plus 6. Okay, now, somewhere I think you learned that if you multiply by powers of 10, like 10 or 100 or 1,000, all you have to do is move the decimal point. Have you heard that?
Yes.
So if you multiply by 10, what do? How many places do you move the decimal point in what direction?
One direction to the right.
One to the right, right? So if in reality, what we could do is we can rename something by multiplying every piece by the same thing, or dividing every piece by the same thing. Well, we're going to multiply. We want 2.4 to become, we don't want that decimal there, so we're going to have to move it one place, which is the same as multiplying by 10. Well, if we do that one by 10, we have to do this one by 10. If we do those 2 by 10, we have to do the other 2 by 10. Well, here's the decimal point in this one. This is going to become 60, isn't it? So we're going to have 24x, take away 3, 0, 3 is 3, is greater than or equal to 3x plus 60. So if we do the same thing to all pieces, we now have no decimals involved. We have all nice integer values. And now let's solve it and see if it does feel a little friendlier. Let's subtract 3x from both sides. 24 take away 3 is 21. Add 3 to both sides. We're still doing the same steps, but we don't have any decimals to deal with. 21x is greater than or equal to 63. And our last step, divide by 21. And we still get the same answer, don't we?
Yes.
X is greater than or equal
2, 3.
to 3. Doesn't that seem friendlier? And you know what, when it's really nice, is when sometimes there's decimals in there. Some of them are out to the hundreds place, and some are out to the tenths, and others are out to the thousands. And then you're like, oh, this is going to be so much work. And then you look at the screen, and they didn't provide a calculator for you on the test question you're doing. You're like, now I got to do it without a calculator besides. So, Cody?
If it's all in the thousands, can't you divide by a number to get them closer to zero?
Well, what you would want to do is what you want to do is in a problem, you want to look to which one is taken out, which one is to the, like if one of them is to the tenths place and one's to the hundredths and one's to the thousands, you'd want to multiply, not divide. You'd want to multiply them all by 1,000. So you'd want to move the decimal point, how many places to the right to multiply by 1,000?
3.
3. So you take every one of the pieces in the problem and you move the decimal point 3 places to the right, and you would get rid of all the decimals that way, and you wouldn't have to. Because if you only multiply by 10, you'd only get rid of the decimal for the tenths one. You'd still have the other 2 that would still be decimal. If you only did it by hundreds, you'd get rid of 2 of them, but you'd still have a decimal left. So you always want to do the one that's the most decimal places, okay? Okay, let's get started on homework.